Hey everyone, Mr. Ray here. We're going to start a new unit today in math. You can tell by the top of this page here, the unit's called trigonometry. Now, trigonometry, that can sound pretty intimidating, I know, for a lot of people that don't know what it is, but it's actually quite simple. Um, if we break the word down, it comes from Latin, which most words do, but uh, this part here, tri, that tri, the prefix tri means three, and a trigon is a three-sided polynomial, which is a triangle. So it's the first part means triangle. The second part here, metrics or metry, that's usually refers to measurement, take the measurements. So this has to do with triangle measurements. So all trigonometry is triangle measurements. And if you think about a triangle, um, you've taken these before in grade 9 and previous years, of course. There's only 6 things we can measure on a triangle, and that's the 3 angles inside and the 3 side lengths. So all trigonometry is determining side lengths and angles in a triangle. Okay, so we're going to be working on this over the next probably 3 weeks, and finish off with one more unit after that. So the first lesson is kind of its own standalone lesson almost. So if you have a tough time with this, don't worry. We kind of start with a separate topic under trigonometry after this lesson, okay? But there will be some questions on the assignment related to this, so obviously it's important to understand this, and it's not really that difficult if you try some questions and work your way through. Okay, so before we talk about similar triangles, I'm going to talk about what the word congruent means. Congruent means all the measurements are the same. So if I have congruent triangles, that would be 2 triangles with all the same angles and all the same side lengths. Okay, basically congruent means identical. So congruent triangles would be identical. Similar triangles, obviously they're not going to be the same as congruent, but they have something. If you look at these 2 triangles, if I asked you to describe how these 2 triangles relate, you may say something like, well, they have the same shape, but this triangle is bigger than this one. Okay, so that's exactly what similar triangles are. The angles in the 3 angles in each triangle relate to angles in the other triangles. So for example here, angle U might be the same as angle B, angle T might be the same as A, V is the same as C, but these side lengths, like if you compared V to C, they're not the same, okay, and U is not the same as B, and T is not the same as A, but if they're similar triangles, you could basically multiply each of these 3 sides by the same number. So maybe this one is, I don't know, maybe this side's 1.5 times bigger. So we would, if you could multiply all 3 of these sides by 1.5, you'll get these 3 sides. Okay, and that's another attribute of similar triangles. Okay, so that number that we multiplied to get the other sides would be called the scale factor. Okay, and the scale factor is down here. Now, how do we get the scale factor rather than just kind of guessing? Well, you'd measure these 2 sides and take the ratio. So maybe this one's 15 centimeters and this one's 10 centimeters. So the ratio, 15 over 10, works out to 1.5, and that would be the scale factor when you multiply these sides to get these sides. Okay, so we're going to be using the scale factor, and we have a variable for that. We call it K. Okay, and we get that by looking at the ratios, or the fractions of we call them corresponding sides. Okay, we'll talk more about this stuff in an example. But there's 2 ways two things about similar triangles. Okay, the thing about the angles we already talked about. We call them corresponding. The angles that match have the same measurements, like A and T, B and U. So B and U have the same measurement, and C and V have the same measurement. And then in terms of their sides, if you took the ratios of the corresponding sides, like the 15/10 and whatever these might be, those would all equal the scale factor. Okay, so we're going to practice this a bit. Now, one thing we do is, hopefully you can see this here, if two triangles are congruent, meaning they're exactly the same, we could basically put an equal sign. We could say, well, I don't have any congruent triangles, but I could say triangle ABC equals triangle PQR. That means they're exactly the same triangles. They have the same side lengths and the same angles. Okay. Now, when there's similar triangles, we can't say they're equal. We use this little wavy sign here. I'll just make that a bit bigger so you can see this. Triangle ABC, and we always put the symbol triangle in front to say this is a triangle we're talking about. We say triangle ABC is similar to, that's what the wavy sign means, triangle PQR. So that symbol there means is similar to. Okay, and we've talked about what being similar means, same angles, and if we took the ratios of the sides, we would get the same scale factor. Okay, so let's try this out, see how we can use it to determine some missing information. Okay, so this one says find missing side and angle measures. Okay, so right here they've actually told us right at the beginning that these two triangles are similar. Triangle ABC is similar to triangle DEF. So there's a couple things that means. Okay, it tells us about the angles. Now it tells us that angle A, and that's the sign for angle, angle A is going to be equal to, now in this case, I don't want you just to look at it and say, well, it must be D or maybe it's F, I don't know. This statement actually tells you, because the position of the letter in this statement tells you which angles are equal. So in this case, A is the first letter, so its measurement, angle A is equal to angle D. Okay, so I'm going to make that statement. I know that's true. Angle B, which is the second letter in that triangle, is equal to, so E is the second letter here, so that's equal to angle E, and the last one, angle C, is equal to angle F. Okay, so let's go into this a bit farther before we look at the sides. So what do we know about the angles here? Well, we know angle A is 28 degrees, so we could add a second equal sign here. We know that's equal to 28. So that tells you that not only is angle A 28, but D is 28 also. Okay, so if you wanted to, you can go in and fill that in into the picture. In fact, let's do that now. So that's 28. What other angles do we know? We know B is 121. So B is here. So not only do we know B is 121 degrees, but also is E. So we can fill that in too. And then finally, we know that angle F, and sometimes we put these around just to emphasize their angles. Angle F is 31. And that also implies that because these two are equal, that C is also 31. Okay, and how can you check that this makes sense? Well, you know that all three angles in a triangle always add up to 180. So if we did that, we would get that these two are 59. We add that to 121. That's 180. That makes sense. And these three angles are exactly the same as these three angles, so they also add up to 180. Okay. So the other thing, let's try to draw an arrow through here. The other thing that statement tells us is that the ratio of the sides are the same. Okay, so now there's three pairs of sides, just like there's three pairs of angles. So we're going to write three different fractions or ratios here. I'm going to start off with just the letters of the sides, just like we did here. So on the top part of the ratios, you have to use the same triangle here. So I'm just going to decide, let's use the sides from ABC on the top and the sides from DEF on the bottom. You have to do that, otherwise if you start mixing them, the ratios become wrong. Okay, so now here the order doesn't matter. So I just think about the three sides. So I know that AB is a side, I know that BC is a side, and I know that the other side is AC. So there's the three sides. How do I know which sides go on the bottom? Well, again, I'm going to use this this statement up here. It's very powerful. So I know that the side that goes with AB, okay, you notice AB is the first and second letters. So it's the side with the first and second letters here. So that would be DE. AB and DE, those are corresponding sides. So I just write that down there. For BC, BC is the second and third is EF. And then AC, it's the first and the third, so first and third is DF. So I didn't even look at these triangles to try to figure out how the sides related. I went directly from this statement. Okay, and sometimes you can't tell by looking at it, and it's not good to do that anyways. You should always take it directly from here. And now what we can do is start filling in, because we have, well, we've got what, 1, 2, 3 different sides, I believe. Yeah. So AB we know is 12.1, so I'm going to put that in. Actually, let's get the fractions already. So I got 12.1. DE, I don't know what that is, so I'll just keep it called DE. BC, I don't know what that is. And EF, I don't know what that is, so I'm just going to leave it like it is. So that wasn't, we don't know much about that ratio at all. And then the last one, AC, is 20.1, and DF is 16.1. Okay. Now, when we solve, what we're going to do is try to solve for one of these missing ones. We only pick 2 of the ratios. Okay, so what they want is the length of DE. Okay, we didn't really read too much farther, but they want DE, so definitely we have to have that ratio as part of our what we solve, because we want DE. Now we get to choose either this one or this one. Now you can tell this one is totally useless. It's not giving us any numbers. In fact, if I use that, I wouldn't be able to get any additional information. Now this one is, we call this a complete ratio. We need at least one complete ratio to solve for some missing values here. So this one is basically useless. So I'm just going to put an X through that, saying we're not going to use it. Okay. Now I'm going to take this. I'm just going to rewrite it just with these two. So 12.1 over DE is equal to 20.1 over 16.1. Okay, now you guys remember from solving equations, you know, we might have something that looks like this. Usually the variable, now the variable here is DE. We don't know what it is. I mean, we could call that X if we wanted to, and then turn that back into DE. But it always isn't that great when the variable's on the bottom of a fraction. And we had ways around it, but what I'm going to suggest for you guys, you see something like this, I would say if these two fractions are equal, then if I flip the fractions upside down, both of them, then those are going to be equal too. So I'm just going to flip. So it's DE over 12.1, and then flip these two. It's equal to 16.1 over 20.1. And now this is a lot better to solve, okay, because if I multiply both sides by 12.1, I'm just going to get DE by itself. So when I multiply by 12.1, it's just on the top of the fraction over here. So I have 12.1 times 16.1 divided by 20.1. And when I do that on the calculator, I get DE is equal to 9.7. Remember it said round to the nearest tenth, so that's what I did. Now, what are the units? How do you get the units? Well, sometimes on the picture they might say centimeters or meters. In this case, they didn't give us. They just said the numbers. So you could leave it like that, or if you want to be impress your math teacher, if the units aren't given, you just call them units. Okay, so that would be the answer for DE. And we kind of already answered the other question, find the measure of C. So from what we did here, we know that C is 31 degrees. Angle C is 31. So we've answered both of the questions. Determine the measure of angle C and the length of DE. Okay, and we use that from this statement here, the fact that these two triangles are similar. We knew that this had to be true. We knew that this had to be true, and then we filled in the numbers that we knew, and that basically gives us the answers with a little bit of calculations. Okay. All right, so here we're going to use a slightly different strategy. The goal is to find the length of FG, which is over here. Okay, so now this might not be very clear. That's a right angle and that's a right angle. Okay, now what makes this question different than the previous one? The previous one actually told us right up front that these two triangles are similar, but they didn't say anything about that here. We can't just say, well, they look similar, so I'm just going to use those rules. You have to show that they are similar, prove that they're similar. So I can't do that by looking at the side lengths because I don't have them all the side lengths. Okay. So what do we know about their angles? They gave us these two angles, but they didn't give us much more. So let's just start putting down what we know. We know that angle G is equal to angle H, and that's because, well, they told us they're both 90. Okay. And so in this triangle, we've got basically two angles called J, one on this triangle, one on this. But because those two angles are formed by two lines across, we call those opposite angles. And, you know, that's 43 degrees. That means that has to be 43. So I'm going to make that statement too. So angle J is equal to angle, angle J. They're both called J because they use that same point. And the reason for that is because they're opposite angles. Okay, now what you can do and what I'd recommend, if you can prove that two sets of angles are the same, well, the third set has to be the same just by default, just because, you know, the fact that we know the other two angles must be the same because both triangles add up to, the angles add up to 180. So if you can prove that a set of two are, then it falls through that the other angles have to be equal. So angle F must be equal to angle I. And you can call that the 180 degree rule because the angles inside a triangle add up to 180. You could have also used, if you remember from grade 9, if we know that this is a little trickier than what I did here, but you could say, well, since these two lines here are both 90 degrees off this line, then these two lines are parallel. And if these two lines are parallel, I have something called the Z pattern here, right? The Z that goes like this. So that must mean that these two angles are the same. So if you wanted to, you could also say, you know, Z pattern here, but you don't have to. You could, if you've shown these two already, you could just say the 180 rule because the three angles must add up to the same. Okay, so because of this, we've got the sets of angles equal to each other. We've just proven that these two triangles are similar triangles. Okay, so I'm going to say therefore triangle, and I'll name this triangle. I'm going to call it JF, and really no specific particular reason for that. I just named the three letters. I could have called it JGF, could have called it FJG. It doesn't really matter. But whatever I chose for the name of this triangle will determine what this triangle is called because these letters have to match up. Okay, So when you're making this statement, you have to be very careful. And the way we know the order is by which angles match up. So here G matches with H, so that means in this triangle H must be the first letter, J is the second, so J is the second here, F is the third by default, so it has to be I. So this you have to be very careful about this, because if you don't name this properly, the next step won't work. Okay, so now that we made this statement that these two triangles are similar, I'm going to make my three ratios just like we did in the last example. Okay, so I'm going to use my I'm going to use this triangle on the top. So I've got that side, I've got that side, and I've got that side. Okay, it's all three sides from this triangle on the top, and then I have to match the corresponding sides from this triangle on the bottom of the fractions. Okay, so and remember the way I do that is by matching up the letters. So GJ is this first and second, so that's HJ. Second is JF, that's second and third. Second and third is JI. And then GF, that's first and third, so that's HI. Okay, so now we'll fill in what we know. And we don't know too much. Now remember, they're asking us to figure out the length of FG, side FG, so this side here. Okay, so definitely, where did that go? That's FG. Well, yeah, FG, that's important. FG and GF, that's really the same side, right? It doesn't really matter what order you put the letters. It refers to the same side. So this is what we're trying to find out. Okay, so now on the diagram, you might want to just call that X, so that when you're referring to that side, you can, for example, I could just call that X, because that's the side we're trying to get. Now for the rest of them, do I know GJ? No, I don't. Right, that side there. Do I know HJ? No, I don't. So not very useful. Then I have JF. So JF is this top line, so that's 18.9. And then I have JI, that's 6.3. And then the GF was X. And the last one, HI, was 4.3. Okay, so just like the last question, remember the last question, we did our three ratios, and then we decided which two are we going to actually use, because you can only use two. So it was pretty obvious which one not to use, because we didn't have any information and we didn't want to know anything from there. So same thing here. So that ratio gets thrown out, and we're left with these two ratios equal to each other. Okay, so I'm just going to switch these around just to put the X on the left side. X over 4.3 is equal to 18.9 over 6.3. If I want to get X, I'm going to multiply both sides by 4.3. So that means 18.9 times 4.3. Give myself some more room here. Times 4.3 divided by 6.3. And that's going to be equal to, once you do the calculator, remember it's to the nearest tenth. So when I round it, it was 12.9. And now in terms of units, again, there's no units given here, so I could just say units. All right, now just to be clear to the person that wrote this wants to know the length of FG. I didn't really say FG down here. So you could have just left this as FG and you're done. Or you could just say, oh yeah, X was FG. Therefore, FG is 12.9 units. And that's your final answer. Okay, so this is an important question because you had to prove that the two triangles were similar first. And we did that by matching up the pairs of matching angles. which we knew from certain information given. And then we made a statement to show, how the two triangles were similar based on the positioning of the letters. And then we used that statement to look at the ratios and then solve for the value we were looking for. Okay, so hopefully that makes sense. But the important part, like I said, you had to prove that they're similar first. Okay, because it didn't say this. It didn't say these two triangles are similar. You have to show that they are, and then use the fact that they are similar. Okay. All right. Last page here. Okay. So in this triangle, we kind of got a triangle inside a triangle. We got like triangle ABC and triangle DBE. Okay. Now, it doesn't say anything about them being similar. It says that these two lines are parallel to each other, and we want to know the length of AC. So that's, we could just put an X there. That's what we're trying to get. And it says in the title, it basically gives us a clue what we're going to do here. Use parallel lines and similar triangles to find missing measures. Okay. So again, it didn't tell us anything about these triangles being similar. So we have to start off by proving they're similar. So this angle B here, this is, this angle is actually in both triangles, the small one and the big one. So I could start off by saying angle B is equal to angle B, which seems to be silly to have to say, but we're talking about angle B in the small triangle is the same as angle B in the big triangle. Okay, and that's because this is a common angle. This isn't opposite in this case, it's just the same angle. Okay. Now, the other two angles, it's based on the fact that these two lines are parallel. So this thing that I mentioned in the first example, if these two lines are parallel, we have something called the F pattern, which you'd see here. This is kind of upside down F, tells us that this angle is equal to that angle. Or you could look at it from this perspective. Here's your F pattern that's also upside down. This angle is equal to this angle. Okay, so we could use both of those for the other two angles. So I'm going to say angle A is equal to angle D, and that's because of the F pattern. And the third one, C is equal to E, for the same reason. Okay, now like I said before, I could have just taken the easy way out here, and it's fine to do that. Once you've proven that this first two sets of angles are the same, the third set has to be equal. So I could have put in 180 degrees here, because the fact that all the angles add up to 180. Okay. Now we've just proven three sets of angles that are the same, so I can make my therefore statement that triangle, and I'm going to do alphabetical to start. Triangle ABC is similar to triangle, and then I have to match up the letters. So A matches with D, so that goes first. Then B matches with B, of course, and C matches with E. So that's just showing that they're similar triangles. And now I'm going to do my ratios. So I'm going to do all three, and I'm going to do it slightly different this time. I'm going to kind of look at, I'm trying to find AC. Okay, so AC is in triangle ABC. So I'd like to have my variable on the top. So that means I want to put the sides from this triangle on the top. Okay, I might have done it anyways, but I'm trying to avoid getting the unknown thing on the bottom, just to make it a little bit easier. So I'm going to do AB, BC, AC. Those are the three sides from that triangle. And then they match up. AB matches with DB, BC matches with BE, and AC matches with DE. Okay. Now I can start putting in what we know about these six sides. So AB AB, so that goes all the way from here to here, so that's actually 12 plus 48, so that's going to be 60. And dB, that's the 48. Notice I'm not putting in centimeters, the units here. It just makes it messy if you do. We'll tack that on at the end of our answer at the end. Okay, BC, do we know that? No, we don't. Do we know BE? No, we don't. So you can tell pretty quickly that that's not going to be of any value. And then we have AC. AC is actually what we're calling X, just to have a little letter, single letter variable, and that's going to be over DE, which is 36. Okay, so now we can take this, and I'm just going to write it. I'm going to start it with that, and that's equal to 60 over 48. Okay, we didn't use that one because it had no value whatsoever. Okay, so now I'm going to solve for x. That means I multiply both sides by 36. So that's x equals 60 times 36 over 48. And when you do that on your calculator, now it didn't say anything about rounding here, so let's just see what happens. It actually works out exactly to 45, so that's probably why they didn't ask us to round it. So that's going to be 45, and the units were centimeters. So this is where I put the centimeters. And then since I didn't say AC is equal to 45, I'm going to say it here in my final statement, 45 centimeters. Okay, so again, just like example 2, we had to prove that these two triangles are similar first by showing that the three sets of angles were the same. Then we make our statement, making sure we match the letters. We make our three ratios, plug in what we know, throw away one of the ratios, and then solve for the value that we're looking for. Okay. All right, last example. Hope everyone's still awake. We have these two triangles, MNP and HJK. There's a lot of information that's given, and I believe it's all put onto the diagram or the pictures. Yeah, so we know all three sides of both triangles. Okay, what we don't know any angles, but we want to show that MNP is similar to HJK. So we can't do that by looking at the angles because we know nothing about the angles. These two triangles are totally separate. They look like they could be similar, but that's not enough to go on. So we do know all six sides. So the way we can prove this, now it's nice of them to actually give us what we're trying to show, so that if we can say if this is true, if triangle MNP is similar to triangle HJK, we know what the ratios should be, and we know that they should be equal. Okay, so I'm going to again, I'm going to do the three ratios. I'm going to put these sides from the MNP triangle on the top. So I've got MN, I've got NP, and MP on the top, and then the corresponding ones, MN matches with HJ, first and second letters, NP, second and third, JK, second and third, and then MP is first and third, so that's HK. Okay, so now it's just a matter of plugging in everything, and we actually know all these values, okay? So MN, that's going to be 4. HJ is 10. NP, 7. JK, 17.5. MP, where is that? Oh, 6. These are all centimeters. Make sure that you're using the same units. 6, and then HK would be 15. Okay, now you could reduce the fractions. It's going to be a little tricky with that one. But if you actually do the math here, 4 divided by 10, that's 0.4. This is 0.4. and this is 0.4. So the fact that these ratios are all the same tells you that, that these two triangles, this statement is true, that MNP is similar to HJK. So I'm just going to restate that. Therefore, triangle MNP is similar to triangle HJK. Okay? So we looked at this from a few perspectives. This was the only one where we actually proved the triangles are similar by looking at their side lengths. On two of the other cases, we had to prove that they're similar by looking at their angles. So either way works. It's just based on what's given to you. Okay. Now the other question, the first question, they actually told us the triangles are similar, so we didn't have to show they're similar. But basically, all the other three, we did have to do that. Okay, so got some homework questions here. Page 25, 1 to 10. If you can try a few of those. There's also resources you could try looking on YouTube for similar triangles. Now, you might see some really complex stuff there. Don't be intimidated by that. Just look for stuff that makes sense to you. Or if you if you're having difficulties, please join me during my office hours on Tuesday and Thursday this week, and we can definitely go through some examples together and make this make more sense. Okay? Thanks, guys, and have a great day.